All right, so we are starting questions 6 through 10 on this exit ticket. It's what you're going to be annotating today. So let's go to the first one. Which of the following is a weakness of the co-accretion hypothesis? So what does the co-accretion hypothesis say? So remember, we read the question first, we go back and we find the key terms here. Earth and the moon both form the same original disk during early formation, blah, 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 coalescent of planets. Because the Earth was larger, the moon became gravitationally trapped, blah, blah, blah. Titanium isotopes reveal that two bodies have similar chemical properties. So, Earth and moon had not originated nearby. They're chemical. So the main point here is Earth and moon have the same origins, at least geographically. Which of the following is the weakness? The moon has a greater density than the Earth. The moon does not contain elements in the same abundances as the Earth. So density has nothing to do with whether or not they came from the same place. B seems like a pretty good answer. The moon, if the moon doesn't have the same elements, then it probably didn't come from nearby. Many other planets have multiple moons. That has nothing to do with, again, origin. Collisions between planet-sized bodies are very rare in the solar system today. So, does this one say that they collided? They coalesced, but it doesn't matter about today. We're talking about the past. So the answer to 6 is B. This one is the only one that discusses elements and formation, which is our main point here. Number 7. In which of the following ways is the chemical evidence cited by the giant impact hypothesis stronger than the chemical evidence cited by the co-accretion hypothesis? So the chemical evidence here. Examination of titanium isotopes say that the Earth and moon have similar chemical properties. Now let's talk about chemicals here. Titanium isotopes are found in similar but not identical abundances because the moon formed from fragments of both the thing. Moon is composed of much less iron than the Earth because most of found in the core, not the mantle. So those are the two things where we talk about different chemicals, different elements. So explains why Earth has an atmosphere, but that's not even mentioned. The giant impact addresses the presence and abundance of both iron and titanium. Well, it does do that, but let's see if that matters. The co-accretion hypothesis does not discuss the origin of different titanium isotopes. And the co-accretion hypothesis mentions elements that are only found on the moon and not on the Earth. Well, that's probably an okay answer, so we're going to cross off C. So between B and D, which one talks about the evidence being stronger? So this is a reason, this one, D, is a reason that the co-accretion hypothesis is weak, but we want why the great giant impact hypothesis is strong. So I know those seem like basically the same thing, because if we're proving one is weak, then the other seems stronger, but we're going to pick the answer that actually proves the other is strong. So that's just a strategy one. So pick the answer that directly talks about, matches the topic in the question. All right, number 8. The giant impact hypothesis mentions but fails to explain which of the following observations. The moon contains less iron than the Earth. There's a because there, so that's an explanation. Celestial bodies formed from secondary accretion disks have relatively high orbital velocities. Let's see, do we see the word velocity? High orbital velocity of the moon suggests that the moon formed from a secondary accretion disk. So it does say that, we'll leave that as an answer. The moon contains more iron than the Earth, but there's a because here too, so that's an explanation. Celestial bodies formed from secondary accretion disks have relatively low orbital velocities. So B and D right here, strategy, are almost identical. So that means we're going to pick one of these. So now let's see which one they say. The high orbital velocity of the moon. High orbital velocity matched our key terms. The answer to 8 is B. Number 9. The giant impact hypothesis hypotheses. That should be hypothesis. That's right. Never mind. Use of the titanium isotope data to contradict the co-accretion hypothesis is incomplete. So this one talks about titanium data too, which is this one's main point. Found in similar but not identical abundances on both the Earth and the Moon. So the abundances of titanium isotopes are not drastically different. I'm going to cross that off because we don't know anything about amounts. No amounts mentioned. We just have similar but not identical. So that's too much. That looks like I spelled it wrong, but I just covered up the E. Titanium isotopes are mostly found in the Earth's core. No, iron is mostly found in the Earth's core, not titanium. The Moon contains more titanium isotopes than the Earth. The Moon contains fewer. Strategy question. It's going to be pick between... pick between... No. Oh, okay, our strategy is proved wrong here. So, the Moon contains more isotope. It doesn't tell me this. And the Moon contains fewer. So, the question here where it says incomplete, right? That's where I was going wrong in this question. So, if it says complete, we would be like, yeah. But because it says incomplete, we want the thing that it does wrong. So, that actual answer is A, because it doesn't mention the amounts. That's the problem. That's why it's incomplete. If this had said complete, we could not choose A. But because it says complete, or because it says incomplete, not mentioning amounts is the problem. So this is one of those questions where you need to find the problem. So if you guys got number 9 wrong, I understand why, because I almost got it wrong too. So you should be picking between these two, but this one actually doesn't match, because again, this does talk about amounts, but we don't have amounts to go from. So pick between these two is wrong in this case. All right, number 10. An astronomer arguing that the giant impact hypothesis might raise which of the following points? So arguing against the giant impact hypothesis. Iron is mostly found in the Earth's core, but the Moon also contains iron. So it mentions that, so that cannot be the answer. That doesn't make any sense, because iron is mentioned in that one on both the Earth and the Moon. If collisions between planet-sized objects were once common, then other planets can be expected to have large moons, yet these moons do not exist. That's a pretty good one. We'll leave B. The Moon has many more craters than the Earth, so we don't talk about craters at all here. So it's not going to be C. No craters mentioned. No craters. The planets in the inner solar system are rocky and much smaller than the outer planets, which are gaseous. That has literally nothing to do with the impact. So our best answer is B. What this one is saying is that if in the old solar system these were colliding, then we should be able to have moons and other things, but we don't.